What's up, everyone? It's Alex. I have just emerged from a frenzy in which I have dove into the matrix of Fourth, and I come returned to the material realm with the solution to day 7, Camel cards. So Camel cards looks a lot like poker, but it's less complicated. So you just have 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, and high card. And what we have to do in part 1 is we have a list of hands. We have to rank those hands and then multiply the rank by the bid, and then sum all those numbers together, and we get the answer. And then in part 2, we turn jacks into jokers, and then we recalculate all the rounds and do the same thing. So this one was a bit of a challenge. So the first thing that we need to do, and this is maybe some of the messier part of this solution, is score the hands. So you have a hand of cards, and you have one of the values that we saw in the problem, and we have to convert in some way. So the conversion that I decided is a 2-digit number, and the 2-digit number represents the most frequent number of cards, and then the second most frequent number of cards. So for example, 5 of a kind is 5-1, 51. 4 of a kind is 4-1, 41. Full house is 3-2, 2 pairs 2-2, and then just a high card is 1-1. This means that it's both relatively easy to generate these numbers, and also these numbers are sortable. So if you represent all of the scores like this, you can sort by those values. So we can ignore the Joker code for just a second. And essentially what we do is we create a buffer of ASCII values, and then we just take the input and then put it into the buffer. So we basically create a bit array of frequencies. So this is like a fourth poor man's collections library, except you just use like direct memory addressing. And we just index this array with the number of values of the number of counts of each card in the hand. And then we iterate over the hand, and then we find the most frequent and second most frequent counts, and then we turn that into a 2-digit number and then return the result. So that's the core. Once we have the hand, so we compare the hands together, and if they're greater, one component of the solution is this CMP function, which is take 2 values, tell me if they're greater, less than, or equal, and I use that in a couple of places. So I use that here in the hand comparison, where the first thing I do is I check if the hands are better, and if they're equivalent, then we go to the hand cards comparison, and this does the tiebreaker, which is iterating from left to right and seeing which hand is higher. So hand cards less than, we basically convert the score using an array, and then we look up the index of the item in this array, and then that's the point essentially of the cards, and then based on those points we compare the hands. And so with those together, we have the hand comparison. And so once we have hand comparison, we insert into an array. So one of the again, the differences between something here and something like Python is you maybe could just sort it after, in a higher level language, you could sort it after inserting it into the array, but I don't have a sort function. And so basically what I do is I just do insertion sort here manually every time that I insert an item. So I have an array here, and then every time we insert, we do a hand check against every item in the array, and then we insert the hand from lowest all the way up to worst hand, all the way up to best hand. And once we do this, we iterate over the array, we sum all the values together and multiply them by their corresponding bids, and that is the solution for part A. So the way that we modify this in part B, it is a little sloppy. I have the Joker mode flag, and if Joker mode is true, then in the hand calculation, we skip adding the Joker at the front, and then at the end, we add the Joker to the highest pointed number. So if you have, 2 pair and then a Joker, we add the Joker to the top value. And one somewhat complexity here is this gets 5 Jokers wrong. It calls it 6. And I could probably rework this to get this right, but I just did this as a special case. And then we also have to rewrite the scoring system here in order to put the Joker at the beginning. So this was a pretty complex problem. Like, it just had a lot going on for it. So it did take me a while. And the solution is not the prettiest in the world, but I think it works. And one thing is, this does take a while, or it doesn't take a while to run, but it doesn't run very fast on the Dusk OS Linux emulator. So I do have to run it inside of QEMU in order to get the solution in a reasonable amount of time. And so that is day 7 of Advent of Code in Forth. Thank you for tuning in. If you like this content, please subscribe, like this video, hit that bell, and see more Forth. Carry forth.